Okay, inequalities. Write an inequality for each graph. So you have -7 going this way. It'd be like -8, -9, all that. So you use all those numbers for x, then -7. Going that way, we got to eat the number because that means the number's bigger than all these. Okay. Okay, 0 and 2. So we put x2. And that'd be like 3, 4, 5, 6. So this time the x, all these numbers that x would represent are bigger than 2, so we have to eat the x when it goes this way with the line under it. Okay, then right here, -6 and 2, we put the word or because the arrows are going apart, they're diverging. We have x and 2. Headed that way, that's like 3, 4, 5, 6, all numbers bigger than 2, so we have to eat the x because that's x, -6, that'd be like -7, -8, -9, that's all numbers less than -6, so then it has to eat the -6, okay. Okay, now with this graph here, we have the arrow, it's converging, okay, that means x can be anything in between these values, so I put x down once, and then I put the maximum value 2 here, and the minimum value -3 here, okay, so 2 is bigger than anything, so the sign has to open to the 2 or eat the 2. -3 is smaller than anything, so we don't open the sign of the -3. It would open to the x. Now we don't put lines when the circles are empty. We do put lines when the circles are filled in. Okay, now let's solve some inequalities and graph the solutions. Find out all the possible numbers x can be. So with inequalities, it's infinite, so you just make a number line. So x plus 3 is less than or equal to 16. So we make a 0 on a number line. And now x has an operation with it of +3. So there's no times, no divide to highlight, so when I take out that, the sign will not switch. The sign never switches when you're adding or subtracting. So -3. -3. So we have x, 16 minus 3 is 13. 13, we circle, we fill it, eats a number, so that would head this way. So you have a maximum, then it just goes this way. Okay, number 6, we have 81 is greater than or equal to -9x. Okay. So -9x, what that means is -9 times x. Okay. Alright, when I see multiplication or division in an inequality, I would want to highlight that. And the reason why is because if that's a negative, you're going to switch the sign. So is there anything we have to add or subtract out? No, there's not. Okay. So when I divide, I know I'm going to switch it because I'm dividing each side by a negative number. So again, if we have negative multiplication, if the variable is multiplied or divided with a negative, we need to switch it because that means I need to divide or multiply both sides by a negative. So we have x, that's me putting switch there. Okay, here I'll write it so you can see it. So if I see you have multiplication or division of the variable with a negative number, we know that the sign is going to switch. 81 divided by -9 is -9. So you have -9 as your critical number. Circle, you fill it, eats the x, so that means it's this way. I know even though it's a less than sign, it still goes that way. Okay, number 7, x divided by -3 is greater than 4. So the only operation we have is the division operation. So again, with a division or multiplication, we want to highlight that. And we have a negative in there, so when I undo that operation, the sign's going to switch. Now there's no operations outside, so we just go straight to the switch and then multiply each side by the -3, because the opposite, to get rid of divide, you multiply. So you have x, and 4 times -3 is -12. So we have -12, we circle, we don't fill it, it eats a number, so that would take the graph this way. The possible values for x means -12 is your maximum. Okay, number 8, we have 4x is less than or equal to 2x plus 10. So just one symbol. When I see one symbol, we just go straight into the number line. We don't need tables or anything. Okay, well, we have x's on opposite sides. We take care of that by either adding or subtracting one of the terms. We want to do the 2x because then I'll still have a 10 on that side. If I take away the 4x, that side's empty of values, void of values. So I subtract 2x, subtract 2x. Now the adding, subtracting, the sign just lines up the same as it was up there. So it's 2x and we have 10. Okay, now we have x on this side. It's a multiplication by a 2, okay? So again, multiplication and division with negatives on that x side. Since that's positive, the sign is going to stay the same. So we're going to keep the sign, keep, okay? Now there's no plus or minus we have to do. We go straight into the division, but remember we're keeping the sign here because that's a positive. So I divide each side by 2. That's going to be 5. Okay. So we have 5, we circle, we fill it. It's eating the numbers, so that would take the graph this way. Okay, number 9. We have 6 times the parentheses x minus 1 is less than negative 18 plus 8x. Okay, now first we have to apply the distributive property into that. Okay, so first off, we have plus negative in there. That's a 1x, so we distribute 6 to the 1x, 6 to negative 1. Now, when you distribute, even if that's a negative, it doesn't matter because you're just doing it on one side, so the sign stays the same. Okay, it's not like you're changing both sides. So drop your plus. 6 times 1x is 6x. 6 times negative 1 is negative 6. And then we have negative 18 plus 8x. Okay, so x's are on both sides, okay? Need to take out one of the x's. Let's take out I'll do the 6 this time. No, I'll do the 8. Doesn't matter, but, so I would subtract 8x, and I'll subtract that from the 6x. So then what does that take me to? Negative 2x plus negative 6. Sign stays the same because all we're doing is subtracting, and then negative 18. Okay, now we can kind of plan ahead here. So I see the x side, you got times, and you got addition. So you're going to highlight the times. And since that's a negative, we're going to switch the sign when we do the opposite of times. First, we have a negative 6 to take out. Now, when I'm taking out the outside number, that's just adding, okay? So when I add or subtract, the sign will stay the same. It's when I divide by that negative on each side where the sign flips, okay? That the switch doesn't come till we divide by that number. So I add 6, we have negative 2 times x, and then negative 18 plus 6 is negative 12. Now we divide each side by negative 2, and that's when the sign flips because I'm taking each side and dividing it by a negative. So we got x, negative 12 divided by negative 2 is 6. Okay, so we have 6, we circle, we don't fill it, it's eating the x, so that would head this way. Okay, next part. Negative 1 is less than or equal to x minus 3 is less than or equal to 2. Okay, well that's a compound inequality. We want a number line for that. Okay, or a table, my bad. The number line will go after the table. So I'm splitting it up. On one side, this symbol, you got a negative 1 value over here, and then the expression x minus 3. So I just copy that onto my table. Then my other inequality, we have a 2 on this side. On the other side, we have the expression x minus 3. So it's going to be x minus 3 is less than or equal to 2. Okay, now we just solve them. Now, we just have the minus operation, so I just have to add 3. Sign will not switch because you're just adding. When you're adding or subtracting, it will not switch. It's when you multiply or divide each side by a negative number. Okay, so that's going to be 2, that's going to be x. Okay, over here, x is not multiplied or divided, just a plus negative 3, so the sign won't change. So we have x, 2 plus 3 is 5. Okay, so So we have 2 on one side, 2 and 5 are both on the positive side. So circle, fill, circle, fill. So with 2, it's eating the x, so that would be this way. With 5, it's eating the numbers, so that's this way. So we have a high and a low. So I put x, put the high there, the low there. You always eat the high, because it's the greatest. You never eat the 2. Okay, number 11, we have 8 plus 2x is greater than or equal to 4, or negative 3x greater than 30. So that's a compound inequality. So we want to definitely be writing that on each side. 8 plus 2x greater than or equal to 4, and then negative 3x is greater than 30. Okay, so, and we'll need the number line afterwards with those to represent the inequalities. Okay, so x is on this side. You got a plus and a times, so you want to highlight the times. Okay, that's a positive multiplying number, so the sign will keep. Okay, we will keep the sign the same. We have to take out the 8 first. Sign wouldn't switch on the 8 part, and the divide by 2 is going to be a positive 2, so the sign's not going to switch there either. So minus 8, 2 times x. 4 minus 8 is negative 4. We divide. Now we're dividing each side by a positive number, the 2, so the sign won't switch. I know that's a negative there, but that's not the number we're dividing both sides by. Okay, it's whatever you're dividing both sides by that you go off of. Now over here you have negative 3x is greater than 30. Okay, so got multiplication. This time the multiplication is by a negative, so when we divide by that, we will switch the sign because we'd be dividing each side by a negative. Okay, I don't have to add or subtract here. Okay, I just need to divide. And when I do that, the sign switches because when I divide, I'm dividing each side by a negative. So the switching of the sign is for multiplication and division by negatives on both sides. Okay, so we have negative 2 and negative 10, both on the negative side of things. So circle. The negative 2 is filled in, but the negative 10 is not. Okay, so with negative 2, you're eating the x, so that would be out this way. With negative 10, you're eating the value, so that's this way, and we have an or. Okay, on ors going opposite ways, we just kind of copy our answers. Okay, number 12, the absolute value of x minus 6 greater than or equal to 1. Okay, absolute value, you need to make a table because it is a compound inequality. You just don't see it yet. Okay. All right, so within the, and since we have the inequality, we'll need the number line at the end. So within the inequality, I have the expression x minus 6. Now I remove the absolute value and represent that with a d variable, d for distance. So it's going to say d greater than or equal to 1. D has no operations with it, so I have it solved for. It's 1. Okay, 1 and negative 1. Now we need to use the given inequality symbol with the positive, but then we need to turn that around when we do the negative. Okay, now we can solve. Okay. You just have the subtraction plus negative, so you don't have to multiply or divide. So when I'm adding or subtracting, the sign just drops. It stays the same. Okay, x, 1 plus 6 is 7. Plus negative, and then we're just adding 6. So if I'm doing an adding or subtracting operation, the sign stays the same. So you have x, negative 1 plus 6 is 5. So we have 5 and 7. So 5 and 7. Circle, fill it, circle, fill it. So with 7, it eats the x, so that's this way. With 5, it eats the numbers, so that's this way. So that's an or. Then you just put them as separate inequalities. So x can be this way or this way. Okay, number 13. We have the absolute value of 5x plus 2 equals 12. Okay. So within the absolute value, we have 5x plus 2, so we're going to need a table. We just don't need a number line after it because it just says equals. So 5x plus 2, 5x plus 2. So I remove that, d equals 12, so there's no operations with d. I already have the value, it's 12. But that could be 12 or negative 12, because the absolute value is distance from 0 on a number line, okay? So equals 12 equals negative 12, now we solve. Okay, the operations you have are times and plus. You take out the plus operation. Now it doesn't matter the operation, it's just an equal sign, so I don't have to worry about switching the sign. Then divide by 5, x equals 2. Okay, 5 times x plus 2 equals negative 12. So I'm going to have to take out my plus 2, then I'm going to have to divide by 5. So I'm minusing 2, that's going to be negative 14. I divide by my 5, and negative 14 divided by 5 is negative 2.8. Okay, so you can get answers. They're discrete answers. We don't graph them. They're not less than or greater than. Okay, number 14, we have 3 times the absolute value of x plus 2, and then plus 4 equals 13. Do not distribute. You can't do that to an absolute value. So within the absolute value, we have x plus 2. Stick with the plan. Now remove the absolute value function from the equation and just replace it with d for distance. Now d's got operations. It's 3 times d plus 4 equals 13. Now we have to undo the operations that are happening on the d side. You got times and plus, so I'm going to minus 4. 13 minus 4 is 9. And over here you have 3 times d. Okay. So to get rid of a multiplication, we would divide. 9 divided by 3 is 3, so d is equal to 3. So we could have 3 or negative 3, and then we solve. Only operation we got is plus 2, so we minus 2, and that's 1. Then I minus 2, and that's going to be negative 5. Okay, story problems. You have 200 feet of fence to put around a rectangular garden. The width of the garden is 40 feet. Write and solve an inequality of possible lengths of the garden. Okay, inequality means you need a greater than or a less than sign. It says have, so it would be less than or equal to 200. Okay, 200 is high as you can go. Since that's a high number, you're going to eat 200. Okay, now let's talk about this. We need to put the 200 feet around 4 sides. 2 of them are L's, 2 of them are W's. So it's going to be 2 times L plus 2 times W, or 2 times W plus 2 times L. It doesn't matter. One of the variables has to be replaced. Well, fortunately, we know that the width is 40. So W equals 40. Now, since that was 2 times W, now it's 2 times 40. We need to find 2 times 40, and that's 80. Okay? So we have 2 times L plus 80 is less than or equal to 200. Now you're ready to solve it. Okay? Now we have multiplication and addition. Okay? So I'm going to subtract 80. So I have 2 times L. Sign ever switch when you subtract? No. 200 minus 80 is going to be 120. Then we divide, okay, by 2. So this side cancels and you have L. The sign switch when you divide, well, it will if you're dividing by a negative here, but we're dividing by a positive, okay? So I knew that that multiplier is positive, so that means we keep the sign the same when we divide, okay? That's 60. Okay, so now we have our inequality. 0, then 60, you circle, you fill it, eats a number, so that's this way. Okay. 15, your goal in history is to get a 90 average for your tests. So far you've gotten a 95, an 86, and 93 on your tests. Write and solve an inequality of possible scores you can get on your next test to meet your goal. Okay. Okay, so we're talking about a goal. A goal is greater than or equal to, and a goal is 90. Okay. Now we're talking average. So average is when you add up for a group of numbers and divide by how many numbers there are. Well, how many numbers are there? Well, I see 3 in plain sight, but there's a 4th one. Okay. So we have 95, 86, and 93. Well, that's only 3 numbers. We need a 4th, so I don't know what it is, so I put X. That's my job to figure out that, because that's in the future. It's a variable. These are discrete numbers. Okay, so I put X plus, then I add my known amounts together. I don't divide them by anything, okay? And that's going to be 264. So you have X plus 264 divided by 4. Okay, now what are your operations? Well, you have plus and division. The division's with a positive, so we'll be keeping the sign the same, okay? We will not be switching it. But we have one whole side divided by 4, so when that happens, I want to kind of group this, and I have to get rid of the divide by 4 first, okay? You get rid of the divide by 4 by times 4. So you want to do that first because you have the whole side is divided by 4. Now the whole side is not divided by 4, but we have to times the other side. Now I am multiplying here, but I'm multiplying each side by a positive number, so the sign will not change. So I have X plus 264, and on the other side, 90 times 4 is 360. Okay, now you just subtract. And when you subtract, the sign never changes. Again, it only changes when you multiply each side by a negative number or divide each side by a negative number. Okay. So it's going to be 96. So this guy's got to do really well to meet his goal here, to get that 90 average. At least I think I did that right. Yeah, I think I did it right. Yeah, I'm pretty sure I did. So 96. Circle, fill it. It's eating the letters, so it'll be this way. 96 or higher. Okay, then my last problem. You're cutting sheets from metal. Each sheet should be 34.25 feet long and 30.85 feet wide. The length and width must be within 0.1 of the desired size. Write inequalities that represent the range of both the length and the width. Okay. Now a range, to find the range of anything, you're going to have a number line. And you're going to have a middle, a low, and a high. Okay, the middle's easy to find. You read the problem, it says long means length. By the way, long also means length. Wide also means width. So if you see those words long and wide, that means length and width. Okay, so length 34.25 and the width 30.85. So I take my 34.25 and I have to add and subtract the variation amount, which is the 0.1. Okay, within is your variation. Okay, so when I add, I get 34.35, and then when I take this minus 0.1, that's 34.15. So I draw circles, fill them because they can be equal, and then connect them. Now we don't need that middle. Okay, so L and then 34.15 on this side and 34.35 on this side. So we eat the high and then eat the L. Equals. Okay, then the width 30.85 plus minus 0.1. So we add, that's 30.95. Then we subtract, that's 30.75. So you circle and fill them. Really don't need that middle anymore because you have your low and your high. So you take W, And on one side you put your lowest, 30.75, and then you put 30.95 over there. So you're eating the high and eating the W.